All right, let's talk about something that is just mind-bendingly cool. It's the math that proves you are who you say you are online. How do you actually sign your name in a world of ones and zeros and do it in a way that is utterly, mathematically impossible to forget? Okay, it all starts with this paradox, really. It's a total brain teaser that's at the heart of pretty much all digital security. So you've got a secret, right? A password, a private key, whatever. You need to prove to someone that you have it, but if you show it to them, well, it's not a secret anymore, is it? So what do you do? Well, the answer is an idea so elegant it almost feels like a magic trick. Seriously, it's called a zero-knowledge proof, and the name says it all. You prove your knowledge while revealing zero information about the secret itself. How is that even possible? To really wrap our heads around this, we're not going to start with some crazy complex equations. Instead, let's use a simple story that computer scientists absolutely love. It's called the story of Ali Baba's cave, and it perfectly captures the logic here. Okay, so imagine a cave shaped like a circle, with a single magic door deep inside that blocks the path. You've got a prover. That's the person who knows the secret password to the door, and they walk down one of two paths, let's say path A or path B. Now the verifier, who's standing outside and can't see which path they took, randomly shouts, "Come out of path A." Now if the prover went in A, no problem, but what if they went in B? Well, they have to know the secret password to open that magic door, cross over, and come out of path A. One time, maybe they got lucky, right? 50-50 shot. But you do it again, and again, and again. After, say, 20 times, the odds of them just guessing correctly are less than 1 in a million. The verifier becomes certain they know the secret. And here's the kicker. The verifier never, ever heard the password. The knowledge is proven, but the secret is totally safe. So that's a cool story, but how in the world do we do that with numbers? How do we build a magic door for our digital messages? This is where the sheer, beautiful power of number theory comes in. It turns out, an old theorem gives us the exact guarantee we need. You see, in our digital world, that secret door, it isn't made of rock. It's a fundamental law of mathematics. It's a relationship between numbers that is so predictable, so reliable, it forms the very bedrock of how we create things like digital signatures. And this is it, Fermat's little theorem. Now, don't let the equation scare you off. You don't need to solve it. The important part is what it guarantees. It basically says that if you take a message, we'll call it M, and you put it through two special mathematical steps, one with a public key and one with a private key, you are absolutely guaranteed to get your original message M back, perfectly unchanged. It's a perfect round trip. And that round trip for your message, that is everything. It's the proof. It shows that the private key used to sign the message and the public key used to check it are a unique matched pair. They're like a key and its one and only lock. No other public key on the entire planet can complete that round trip with your private key. The math itself creates this unbreakable link. So, what happens when you take this mathematical guarantee and you unleash it on the world? Well, something profound starts to happen. When our proof is based on a mathematical law, instead of just a person's word, we can build systems where we don't have to trust a middleman. We can just trust the math. We call this trustless math. And think about what that really means. To verify a signature on a paper contract, you might need a notary public, right? A trusted person to stamp it. In this world, the equation is the witness. Authenticity isn't a matter of opinion or faith in some company. It's something you can calculate and prove for yourself, right on your own computer. I mean, just look at the comparison here. A human witness, they can be biased, they can forget things, they can just be plain wrong. We're all human, right? But a mathematical witness, it's completely impartial. It's verifiable. It's absolute. The math doesn't have a bad day. It just computes the truth. This mathematical certainty leads us to this incredibly powerful idea called non-repudiation. Now, it's a big word, but it stands for a really simple idea. You can't take it back. It's the absolute assurance that the person who created a digital signature cannot, at some later date, turn around and deny that they were the one who made it. And this all boils down to one simple, powerful conclusion. As our source material puts it, mathematically, only the holder of the private key could have generated the signature. Denial is impossible. That's it. That's the power of this whole system. The link is absolute. The signature is unforgettable, and it's undeniable. So let's just pause on that for a second. We've taken the idea of a signature, of your unique identity, and we've transformed it from a physical scribble into a mathematical proof. And that's amazing for security, no question. But it also leaves us with this huge question we all have to think about. If your signature is just the result of a calculation, what does it really mean to own your identity in this new digital world?